Hello my dear students, this is Akash SD and welcome to the ASD physics classes. Students, hope so doing really great. So today we are going to solve conservation of angular momentum based question from the chapter rotational motion. In this question of JEE 2024, we are going to learn very important concept that is important for our NEET exam also. So let's students go through the question. Question is, consider a disk of mass 5 kg, radius 2 meter, rotating with a angular velocity of 10 radian per second about an axis perpendicular to the plane of rotation. After that, an identical disk is kept gently over the rotating disk along the same axis. The energy dissipated so that both the disk continue to rotate together without slipping is. Okay. So before starting this question, we should know moment of inertia formula. So according to the question, axis is passing through the center of the disk and perpendicular to the plane of the disk. Then you can guess very well what is the moment of inertia formula. The moment of inertia formula of the disk will be half mr square. Okay. Mass value how much given in the question? 5. Okay. Radius how much given? 2. So it will become here 5 into 4, 20. 20 by 2, how much? 10. That means 10 unit, 10 kilogram meter square. Now moment of inertia we know very well. Now after that, if we talk about the question, this disk is there. This is the disk and rotating with the angular speed omega I. Anyhow, moment of inertia is I, that we have calculated separately. So what will happen, dear students? First we are going to calculate the initial angular momentum formula, I into omega I. I how much we calculated? 10. And initial angular speed how much given here? 10. So 10 into 10 how much here? 100. Unit of the angular momentum, remember that please, kilogram meter square per second. Is it? After that, if we talk about here the energy carried, EI, energy carried, what is the formula? Half I omega square. So half moment of inertia already we have calculated, 10 and omega I square. Omega how much? 10. So it will come here 10 square. So when you will simplify this, how much it is coming? It is coming here the 500 joule. Now our initial condition is ready. Now what we have to do according to the question, see, this is the disk is there now. Above the disk we are going to put another identical disk gently like this. Now, and let's take here in this situation, it is rotating with the angular velocity omega f. Okay. So what will happen in this situation? We have to apply conservation of angular momentum. Question will come like disk is kept gently, point mass is kept gently. Now, so what we have to do? We have to apply conservation of angular momentum. So according to conservation of angular momentum, what will happen? Final angular momentum will be equal to initial angular momentum. Now see please, angular momentum formula is what? I omega. So see here please, here how many disks is there? 2 disks. So I plus I, what will come? 2I. And here omega f, and initial angular momentum what we have calculated? 100. Okay. Now kindly put the value. 2 I value what we know? 10. And here omega f is equal to 100. So here when we will simplify this here, omega f will come how much here? 100 by 10 into 2, 20. So it will come here 5 radian per second. We have got the final angular speed. After that, what we have to do, according to the question, we have to calculate the energy, is it? So what is the final energy? EF. So energy formula is what? Half I omega square. So half I omega f square. But students, here how many disks is there? 2 disks is there. This one is having energy, this is also having energy. That means we have to multiply this expression with 2. So this 2 and 2 will cancel out. That means it is coming here I omega f square. Again, I how much? 10, correct? And omega f how much we have got? 5. So it is coming here 5 square. So how much it is coming here? It is coming here 250 joule. Now in the question what we have to calculate? In the question we have to calculate this one, the energy dissipated. Energy dissipated. Now energy loss will happen. So to calculate the energy dissipated, even we can do E final minus E initial. E final minus initial. E final how much here? 250 minus E initial how much we know? 500 joule. So here what is coming here? 250 minus 500, we can tell here minus 250 joule. So this minus sign is indicate that energy is dissipated, or we can tell students here final energy is less than the initial energy.